In our last video, we looked at factoring a quadratic binomial equation. I've got one more thing to show you with that. So to do so, let me do a little sharing of the screen. So as we take a look at solving, and before we get to that solving, here's the factoring part. The one thing left I want to share with you, and that is, can you use a greatest common factor and a difference of squares at the same time? And the answer is you bet. Let's do it. So if we take a look at 2x squared minus 50, taking a look, what do 2x squared and 50 have in common? Well, we could think of this a couple different ways. One is we could break each part down, or we could just go, hey, I know what they both have in common. They both don't have an x, but they both are divisible by 2. So I'm going to divide 2 into 2x squared and negative 50. So 2 times x squared, that'll give me my 2x squared. And 2 times negative 25, that will give me my negative 50. Now some will look at this and go, whoo, I'm done, I factored it. But it's not factored all the way. So here's what we can do next. What we've got to do is now I've got to look at this x squared minus 25 part and go, oh, that's a difference of squares. So what I'm going to do is I'm going to bring this 2 down. And I'm going to factor x squared minus 25 into x plus 5 and x minus 5. Now, if I were to multiply all of that out, I should get 2x squared minus 50. So, you know what? Let's do that. Let's do the orange part first. Let's take x plus 5 times x minus 5. So that'll give us x squared, 5x, negative 5x, and negative 25. You don't have to write all that down in blue right there. That was very, very fast. So 5x and negative 5x adds together to become 0. So I'm left with x squared minus 25. But now I have to take that times 2. So 2 times x squared is 2x squared. And 2 times negative 25 is negative 50. And we've got a double winner. That's what I'm looking for, 2x squared minus 50 right there. All right, that's factoring. Now let's look at the solving part. Now, solving and solutions are actual answers, like x equals 5 or x equals 0, okay? So there's 4 steps that I've laid out for you. 3 of the 4 we need to really focus on every time. The 4th one is optional. And we'll do it one time just to kind of show you how it works. So when we solve, we're looking for, if we were to graph this equation, where does this graph cross the x-axis? Okay, so just recall, quadratics are parabolas. So there might be 2 solutions. There might be 1 solution. There might not be any solutions. Okay, so as we explore this, not only in this course, but later on in Algebra 2, those are the things we got to consider. Okay, before factoring, make sure the equation is equal to 0. We cannot solve a quadratic until it's equal to 0. The second step, we want to try to factor it using the greatest common factor or a difference of squares, or both, like in the example above. And we're going to look at steps 3 and 4. Those are the new ones here in a moment. All right, let's do H. All right. So in doing H right here, let's do this. All right. So 2x squared plus 14x equals 0. It is equal to 0. So step 1 is done. I have to factor. Now, if I look at 2x squared and 14x, is there a greatest common factor present? The answer is yes. I can remove a greatest common factor of 2x from 2x squared, which would leave me an x, and I can remove a 2x from 14x, which leaves me a 7. Still equal to 0. Now, does it check? 2x times x is 2x squared. 2x times 7 is 14x. Yes. If that is not correct, then I should not go any farther. All right. Now, step 3 up above says we've got the 0 product. Okay. So think about this in math. If you had 0 times 5, 0 times 5 is 0. What if you had 5 times 0? Well, it's still 0, isn't it? If one of the factors is 0, it doesn't matter what the other factor is. It's still going to have a product of 0. Okay, so we're going to use that principle here, and what we're going to do is we're going to set both factors equal to 0. And solve. Okay, well, the first one's really easy. They're actually both easy. We have to think 2 times what is 0? Well, it's 0. We could do the algebra. Don't really have to, because 0 divided by 2 is 0. There's a solution. And the second one, what can we add 7 to get 0? That's -7. We're about at the end of algebra 1, so I'll show the work. There's -7, and there's your 2 solutions. That's step 3. Now, in theory, we're done, but I want to show you this. How can you check it? How do we know for sure? Well, what we can do is we can take our 2x squared plus 14x equals 0, and let's say that if x equals 0, does it work? So let's plug it in. So 2, there's an x, so it'd be 0 squared plus 14 times 0 equals 0. So 0 squared is 0, times 2 is 0, 14 times 0 is 0. We get 0 plus 0 equals 0. Checks. Let's try a -7. Okay, so 2 -7 squared plus 14 times -7, that should equal 0 as well. Okay, some bigger numbers here, but you'll get the idea. -7 times -7 is 49. 49 times 2 is 98. 14 times -7 is -98, and that equals 0. So, checks. Okay. So there we saw the greatest common factor. In this one, we're going to see the difference of squares appear. All right, let's look at it. Find the solutions to x squared minus 100 is equal to 0. There is no greatest common factor. But we do know that this is really x squared and 10 squared. And following that difference of squares principle, we know this is going to factor into x plus 10, x minus 10. And again, it was already equal to 0, so it was legal for me to factor that. These are the factors. Okay. Just like up above here. These are the factors. So 0 and -7 on the last one were the solutions. So to find the solutions here, I'm going to set x plus 10 equal to 0, and I'm going to set x minus 10 equal to 0. Doing the algebra, I'll get -10 for one solution and 10 for the other. Now I can also write this as x equals positive and -10 as my solutions. So I can write them separate, or I can write them with that notation too. I could check it to verify it, just like I did last time if I wanted to as well. Here's J. Find the solutions to this, and one thing we notice right away is we have a problem. This is not equal to 0. So the first thing I have to do is I have to move the 41 over to the other side by subtracting. Gives me 3x squared minus 27 equals 0. Okay, so had to actually do an extra step there. So looking at 3x squared minus 27, they both have a 3. That's the greatest common factor. So if I take a 3 out, that'll leave me with what? X squared and 3 times 9 is 27. Notice it's still equal to 0. Okay, well, I still have a quadratic inside the parentheses, and I notice that, hey, it's what we started the video with. It is a difference of squares. In fact, x squared minus 9 factors into x plus 3 and x minus 3. Hey. So how do you find the solutions when you have 3 factors and not 2? Well, think about this. If I list everything out, and for the sake of space, I'm going to list all 3 factors equal to 0. I'm going to say 3 equals 0. I'm going to say x plus 3 equals 0 and x minus 3 equals 0. Well, we have a problem with the first statement. 3 equals 0? No. You can't do that. We can't get a solution out of that. Now, because it's x squared, I could have 2 solutions maximum, all right? So setting x plus 3 equal to 0 gives me a solution of -3. And doing the same on the bottom here, I get 3. So these are my solutions right here. Where all of this down here, that was the factors, including the 3. Okay, pause the video. I have one left for you. It's got a little twist to it. I think you'll be okay. But I want you to factor and solve 3x squared minus 25x is equal to 0. Pause, and I'll be right back with you. All right, take a look at it. 3x squared minus 25x equals 0. Is it equal to 0? Yes. Is there a greatest common factor? Yes. Both terms have an x. And that leaves a 3x minus 25. Okay. And you're looking at 3 and 25 and you're going, they don't have anything in common except 1. I know. It's okay. So I'm going to set each factor equal to 0. So x will equal 0. Hey, that was easy. And I'm going to set 3x minus 25 equal to 0. There's one solution right there. How do I get the other solution? It's a 2-step equation that I have to solve. I shall add 25 to both sides. Leaves me 3x equals 25, and I shall divide by 3. My other solution is 25 over 3. All right. Is it possible to get fractions? Sure it is. It absolutely is. Now, what do I know? What I know about this is if I put this on a graph, last thing, I would have a solution at 0. I would have a solution at 25/3. That's 8 1/3. It's over here somewhere. And because I have a leading coefficient that's positive, this is going to open up. So I'm going to end up with the graph that looks something like that. That's the power of factoring, and that's the power of solving binomial quadratic equations. It leads to a lot of cool things that you do in future math courses, and also a lot of super cool things that you can do in the sciences as well. Thanks for watching.